Welcome to The Explainer. Today we're conquering the big three. Yeah, the exact topics in Kubernetes that make most people just quit. We're going to demystify them, simplify them, and get you a giant leap closer to certification, starting right now. That's right, we are talking about networking, service mesh, and storage. And let's be honest, Kubernetes networking is famously the #1 reason people throw in the towel on their K8's journey. It can feel like this impossible maze of IPs, proxies, and plugins. But what if I told you that the entire complex networking model really just boils down to 4 simple roles? I mean, once you get them, everything just clicks. And what if we could conquer not just networking, but service mesh and storage too, all in the next few minutes? Because by the end of this explainer, you have covered 68% of the KCNA exam's entire domain too. You're literally just minutes away from mastering the concepts that separate the beginners from the pros. Okay, let's dive in.
All right, Section 1, Kubernetes networking. Look, don't let the complexity fool you. At its core, the whole system is built on this foundation of 4 golden rules that, honestly, make everything work together seamlessly.
First, and this is the big one, every single pod in the entire cluster gets its very own unique routable IP address. Think of it like this. Every house on a street has its own mailing address. No sharing, no confusion. Simple. Second, because every pod has a real IP, all pods can talk to all other pods directly. There's no complicated network address translation, NAT getting in the way and rewriting addresses. It's just a flat, open network. Third, this direct line of communication extends to the nodes themselves, the actual servers running your pods. They can also talk directly to any pod on any other node. And again, no NAT needed. And finally, rule number 4, no identity crisis. The IP address a pod thinks it has is the exact same IP everyone else in the cluster uses to reach it. See? These 4 rules create this simple, predictable network where everything just works. If that just clicked for you, do me a favor and comment 4 rules below. Now, to make this even simpler, just think of your whole cluster like a company phone system. Each pod is like an employee with their own unique extension. A service? Well, that's the department hotline that knows how to ring the right employee. An ingress? That's the friendly receptionist, directing all the calls from the outside world. So who provides this home system? That would be the CNI, the Container Network Interface. It's basically the plugin that makes those 4 rules a reality. And you've got choices. Calico is the enterprise favorite, mostly for its awesome security policies. Flannel is super simple. It's perfect for when you're just learning. And then there's Cilium, the new powerhouse on the block, using some cool tech called eBPF for incredible performance. Okay, so pods can talk to each other. Great. But there's a problem, right? Pods are ephemeral. They come and they go. So how do we give them a stable, reliable endpoint, that department hotline from our analogy? Well, the answer is a Kubernetes service. And you've got 4 main types of services to pick from. The default is cluster IP, and that's for internal-only traffic. Think of your app talking to its database. Then you have node port, which opens a port on every single server in your cluster. It's great for quick tests. For production, you're going to use a load balancer, which gets you a real public IP from your cloud provider, but it does cost money. And finally, there are headless services, which are a special case for stateful applications. And this brings us to a huge exam tip. Listen up. You almost never create a load balancer service for every single application. Instead, you create one load balancer for an ingress controller, remember our receptionist, which then intelligently routes traffic to all your different internal services. This saves a ton of money and just makes your whole setup way simpler. Now for Section 2, the service mesh. So once you have your basic networking and services humming along, a service mesh comes in and adds this layer of superpowers right on top. It sounds really complex, I know, but all of its power comes from one simple, really elegant pattern. So a service mesh works by automatically injecting a tiny little network proxy, called a sidecar, right next to each of your application containers inside the pod. This little proxy intercepts all the incoming and outgoing network traffic. And the best part? Your application doesn't even know it's there. This simple pattern unlocks some absolutely incredible superpowers. It can automatically encrypt all your traffic with mutual TLS for rock-solid security. It lets you do advanced traffic splitting for things like canary releases. It can do what's called circuit breaking, so it automatically stops sending traffic to a failing service. And it gives you amazing observability, like distributed tracing, all without changing a single line of your application code. It's magic. The two big players you need to know are Istio, which is the original and most feature-rich option out there, and Linkerd, which is famous for being incredibly lightweight and super simple to operate. Okay, we've covered networking and the service mesh. Go ahead and hit that subscribe button so you don't miss the final piece of the puzzle, storage. All right, let's get into our third and final section, mastering storage. We've conquered networking and service mesh, but since pods can just disappear at any moment, how do we make our data actually, stick around? We need a way to manage persistent storage that outlives any single pod.
The key is to understand this hierarchy. It all starts with a storage class, which defines types of storage, like fast SSD or cheap and slow. An admin then provisions a persistent volume, or PV. That's the actual block of storage. A developer then comes along and requests that storage with a persistent volume claim, or PVC. And finally, the pod consumes that claim, mounting it as a volume to store its data.
Now, a huge topic for any certification is access modes. This just defines how pods can mount that volume. Read-write once, or RWO, means the volume can be mounted as read-write by just a single node, perfect for a database. Read-only many, or ROX, means lots of nodes can read from it. And read-write many, or RWX, means many nodes can read and write at the same time, which you'd need for something like a shared file system.
And here's the big idea that really ties it all together. Kubernetes uses standardized interfaces for everything. The CNI we talked about, that handles networking. The CSI, that handles storage. And the CRI, or Container Runtime Interface, handles the containers themselves. This whole pluggable model is the real secret to Kubernetes power. And just like that, you've done it. You have faced the three biggest hurdles in Kubernetes, and you absolutely cleared them. Networking, service mesh, and storage are no longer these big, scary mysteries. They are now tools in your toolkit.
So congratulations, you have just powered through the core content for Domain 2 of the KCNA certification. You are now 68% of the way through the material covered on that exam. That is a massive, massive achievement.
Hey, if this explainer helped you conquer the big three, let us know by commenting Domain 2 done below. And for sure, make sure to subscribe, because in our next session, we're tackling how to automatically scale your applications to millions of users with the horizontal pod autoscaler, the vertical pod autoscaler, and the cluster autoscaler. You are not going to want to miss that. See you then.